So welcome everyone to the first session of the Climate Smart Floridians webinar series. This is going to be a 6-week series talking about climate within Florida and really a lot about what you can do and sort of the things that relate to you within your work, home, community related to climate in Florida. So this first session will be an overview of climate and sort of just the basics so we can all be on the same page as we're sort of moving forward within this program and within this series. And the next slide will show the topics that we have for all the following sessions. So we'll be learning about green building and energy. That is going to be a really exciting session coming up. We'll be talking about water, of course, and food. We'll have a session about Florida-friendly landscaping and that whole program that we have within the University of Florida IFAS Extension. And then we'll end with consumption, which is a really exciting topic. We always get a lot of great discussion when we talk about that. I should introduce myself. My name is Holly. I am a Florida Sea Grant Extension agent with the University of Florida IFAS Extension, and I'll be one of your speakers eventually, but also one of the moderators for this series. So you'll get to hear from a bunch of us who will be speaking. And I'm really excited to introduce Megan Moore today. She's going to be our first presenter, and she's going to be discussing Climate 101 with all of you. So she'll be giving that overview, and there'll be plenty of time for questions at the end. So during the presentation, if you want to put any questions in the chat, we can address those at the end of Megan's talk. But if during the session any of the moderators feel like they can answer your question in real time, we will do that as well. But again, we'll have plenty of time at the end for questions. So please add those to the chat. If you want to introduce yourself and where you're coming from, that is great too in the chat. So we can get to know each one of you and where it is that you're coming from. So with that, I will turn it over to Megan.
All right. Well, thank you, Holly. Hello, everyone. Thanks for coming today. Again, my name is Dr. Megan Moore. I'm the Florida Sea Grant agent here in Pasco County. So today I'm going to be talking to you about Climate 101. We wanted to start this by kind of picking your brain. So if everyone wants to in the chat, you can put a word or phrase that comes to your mind when you think about how our global climate is changing. And this can be anything you think of, how you think about our changing climate, how it's been communicated to you. We just kind of wanted to see what is in your head at the beginning of this and what you're thinking about. So we'll just give you a couple moments here to type some of those words into the chat.
Yeah, so we see sea level rise, tropicalization, resiliency, clean energy, unpredictable weather, more energy, greenhouse gases, melting glaciers. These are all great. Loss of biodiversity, water scarcity, carbon, carbon, carbon. Yes, definitely.
Okay, yeah, those are all really great ones. It sounds like we have a lot of people who think of causes or things that are happening due to our changing climate. I think one of them was resiliency too, so people are thinking about some solutions we might have. So if you think of more, feel free to put them in the chat, but we'll move on for now. So, before we start talking about what climate is, I think it's important that we note that there's a difference between weather and climate, which some people often get confused. And so, it's important to know that these are not interchangeable terms. So, we're going to kind of define each of these for you. So, first, when we think about weather, these are short term conditions of the conditions outside. So, if anyone's near a window right now and you're looking out, the conditions you see presently, that's the weather. These are usually daily to weekly variations. So, things like thunderstorms, a cold front coming through. It could rain in your city, but not the city next to you, and they can change really rapidly. So, for example, today where I'm at, we had this cold front come through. I'm sure a lot of people in Florida experienced this, and that's an example of local weather happening. And these variations can be a little bit more hard to predict than climate. So when we talk about climate, this is a little bit different in that it's the long-term average conditions of weather in a region. So these can be much larger areas that are covered by these climate conditions. And when we say long-term, it's usually an average of about 30 years. So these are seasonal changes. For example, in Florida, we know that our winters are colder than our summers, but compared to somewhere like New York has a much colder climate than Florida does. You can also think about this like the tropics. So near the equator, we say they have a tropical climate. They're going to have warmer, more humid conditions, and these are predictable changes. So these are measured over very long periods of time, and we can tell what the overall weather patterns are going to be like in these areas. Now, when we're talking about climate and the things that are affecting it, we kind of break this down into two factors. So we have abiotic and biotic factors. Abiotic is going to be anything that's non-living that is shaping the environment and the climate. And biotic factors are going to be how living organisms add to or shape the climate in that environment. Now, abiotic factors are going to be physical or chemical influences, and these kind of make the larger overscaling changes to the climate patterns. Biotic, again, these are the living things. These are going to be not necessarily smaller, but they interact more with these abiotic changes and can add to these feedback effects. Now, I think these can get a little hard to confuse in your head, so I think it's best to see some examples. So when we're talking about abiotic, again, non-living parts of things that change our climate, we're talking about some of these examples. So latitude, if you live close to the equator, you're going to experience a different climate than if you live up near the poles. Altitude, of course, if you're living at the top of a mountain, you may have different climate than someone living at sea level. Ocean currents are an interesting one. In Florida, we have the Gulf Stream current that runs near us, and it's bringing warm water up from the equator, so we tend to have a warmer climate. Whereas over in California, for example, their ocean current runs from the north to the south, so they tend to have a colder climate as that Arctic water is brought down. We can have variations in the solar radiation, so the actual intensity of the sun, and that can change our climate, and similarly orbital variations. So this is things like how Earth is actually moving through space relative to the sun, the shape of our orbit, the tilt of the Earth. These are all things that change slightly over long periods of time, but they can actually affect the global climate. And then more on a geologic scale, volcanic activity or the movement of our tectonic plates add to our climate as well. Now, when we're talking about biotic factors, again, remember these are the living organisms that shape the environment. There are several processes that living organisms do that change local climates or global climates. One would be transpiration. So plants can pull water out of our soils and evaporate it and release it into the atmosphere along with other gases. Respiration, this is when CO2 is being released from plants or animals, CO2 being carbon dioxide, which is a greenhouse gas. Photosynthesis, this is when organisms or plants use solar energy and can draw down some of these greenhouse gases. And then decomposition and digestion is the breakdown of organic matter, and that can release greenhouse gases as well, which influence our climate. So we have this strong relationship between non-living and living factors that both impact our climate globally. Now, when we're talking about changes to our climate, one of the largest contributors are our greenhouse gases. Now, when we're talking about all of the gases in the atmosphere of the Earth, we have a pretty generic makeup. So we have about 78% nitrogen gas in our atmosphere. Oxygen is about 21%, which may surprise you. I'm sure you know that we breathe oxygen, but it's not actually the primary gas we breathe. It's just important that it's about that level. We have argon, which is a noble gas, and then all of the greenhouse gases fit in this other 0.2%. And even though that's a very small sounding percent, even this little variation can cause major effects when we talk about the greenhouse gases. So before we start talking about how these greenhouse gases impact things and vary, it's important that we understand what they are and how they're impacting us. So when we're talking about greenhouse gases in our atmosphere, we have four main contributors. The first is water vapor. So water vapor is naturally occurring on Earth. It's primarily in the atmosphere due to the evaporation of water. It can come from oceans, lakes, rivers, or any other water source on Earth. It's the most abundant of our greenhouse gases, and it's really important in that water vapor creates a positive feedback loop. So what this means is that water vapor causes warming of our atmosphere. Warming causes evaporation, which causes more water vapor, and that causes more heating. So we kind of see this positive loop where the warmer we get, the more water vapor that is created into our atmosphere. Next, we have carbon dioxide. So carbon dioxide is another natural component of gases in our atmosphere contributing to the greenhouse gases. Naturally, it forms through the decomposition of organic material, from wildfires, or from respiration released by plants and animals, but it can also come from geologic sources like volcanism. We have methane. Methane usually occurs from several processes. It can come from the decay of organic matter in low oxygen environments. So this could be somewhere like swamps or wetlands. Animals produce methane. So cows actually produce a large amount of methane as they're digesting their food. And then we can have methane seeps underwater as well that are very common. And although methane generally occurs in lower concentrations, it's a very powerful greenhouse gas. Lastly, we have nitrous oxide. So oxide is usually produced during the nitrogen cycle, often due to bacteria that are living in the soils, and this can occur due to the decay of organic material. It can be in forests, wetlands, along the ocean floor, or any really organic rich soil. Now, the reason that these greenhouse gases are so important to us is that they make our atmosphere hospitable. So, all these gases are existing in this atmospheric layer above Earth. The sun transmits the solar rays, which create radiation and heat. And normally these rays would just bounce back off of the Earth's surface up into space. The atmosphere is so important because it traps some of these rays and reflects that heat energy back towards our Earth's surface. So it's the carbon dioxide and the other greenhouse gases that are helping to keep our Earth's surface warm so that it's not freezing like out in space. And this is the reason we can support life. So if you look to other planets in our solar system, we don't see life like we have here, and that is largely because they don't have similar atmospheric conditions. Now we're going to mainly focus on carbon dioxide for the remainder of this talk, as carbon dioxide is a very important greenhouse gas, and we see impacts related to how it's changing our climate. So when we're talking about carbon dioxide, it's important to understand the carbon cycle. So carbon is naturally cycling on Earth between the atmosphere, the land, the ocean, and all living organisms. Generally, we have a set amount of carbon that exists on Earth, and it's just constantly cycling between these different systems. So all plants, animals, and living things on Earth are made out of carbon. However, we also find it in the air, in soils, in rocks, and in the ocean as well. So in the atmosphere, when we're talking about carbon, it mainly takes the form of carbon dioxide. You may see CO2, that's the kind of shorthand chemical equation for carbon dioxide, so I might say those interchangeably. But carbon dioxide is going to exist in the atmosphere. Plants and some living organisms will pull that carbon dioxide out of the atmosphere during processes such as photosynthesis. On the short term, living things like animals can eat plants, incorporate that carbon into their body, and both plants and animals will respire or release carbon dioxide back into the atmosphere. So, on the short term, we just see the carbon dioxide moving from the atmosphere to living things and back. However, on a longer scale, decaying organisms, so as plants and animals die, they'll get incorporated into the soil and over long time scales can become part of the fossil record. So as they get compressed over geologic time, they eventually become what we call fossil fuels. So this can be things like oil, gas, and it's really just concentrated carbon. Now, in a natural cycle, this carbon would remain in Earth's crust for thousands, hundred thousands, millions of years before it's eventually recycled either into the Earth's mantle. It can be melted down and released by waste through volcanism. However, something that is occurring in today's world is that humans are extracting fossil fuels to use them for energy. So as we extract oil, gas, and things like coal, we're breaking that down, using it to run factories, using it to create energy and power our cars. And what that's doing is releasing carbon back into the atmosphere at a very fast rate. So this natural cycle of moving between the atmosphere, the soils, the oceans is being disrupted as the Earth can't naturally accommodate the rapid flux of carbon that we are putting into the atmosphere. Now we see a direct correlation between these increased greenhouse gases and temperatures. So this graph here is showing you the annual greenhouse gas index, and what that shows is the increase in warming related to greenhouse gases. Now they set the baseline, so at 1990 would be 1, and we just see a general increase in greenhouse gas warming related to time. Now, what I really want to take away from this is that as our greenhouse gas index is increasing, we're seeing increased warming. And associated with that increased warming, we have impacts to our globe and our local environments that are being impacted, and we have predictions of what is going to continue happening moving into the future. So impacts that we already see of this changing climate are we see our global temperatures increasing. We're seeing increased carbon dioxide emissions that have been growing rapidly since the Industrial Revolution. Since 1993, we've already seen a global sea level rise of nearing 4 inches. Our ice sheets are shrinking. We're experiencing more flooding related with high tides. Our hurricanes are changing their characteristics. They're slower moving, higher intensity. And we're having impacts of ocean acidification, where the ocean dissolves too much carbon dioxide in it and becomes more acidic, impacting sea life. Now, moving into the future, we're going to see a lot of these concerning issues continue. Sea levels are predicted to continue to rise. Global temperatures will continue to increase. Our frequency of tidal flooding and sea level related flooding are going to continue. Our oceans are going to continue to become more acidic. We'll see changes in precipitation as well. So this doesn't necessarily mean we'll see a lot more rain everywhere. It could mean that some areas experience more rainfall, where other areas experience extreme drought. So it's more the variability in the weather conditions related to precipitation. And we also expect to see additional disease and health related issues impact populations related to this changing climate. Now we have evidence that the climate is actually experiencing these changes. We have rising temperatures that are shown by measurable data. So this graph here on the left scale is showing you the change in temperature in degrees Celsius since the 1850 to 1900. So they averaged the temperatures between 1850 and 1900, and then everything plotted beyond that is showing either an increase or decrease in that average temperature. So you can see between about 1850 and the 1940s, we still had some variation where some days were warmer and some days or some years were cooler on average. But after around the 1950s, every year had been warmer than the first or than the late 1800s. And we've seen that trend continue. We also see that starting around the 2000s, we have a much sharper climb in temperatures where the rate of temperature rise has been occurring very rapidly. You can see in the past few years, we have been nearing a temperature increase of about 1.5 degrees Celsius or nearing 3 degrees Fahrenheit above the pre-industrial temperatures. And this is so impactful that we actually see that the past 12 years have been the hottest 12 years on record since the 1800s. So we continuously see that temperatures globally are warmer and they're staying warmer. To give you some more examples associated with this, in 2024, it was the warmest year we had seen on record, both on land and sea. And this occurred in both the northern and southern hemispheres. So that's showing that we're having this global rise in temperature, and it had just passed the hottest previous year of 2023. Now, 2025 dropped a little bit. This is just due to natural variations. You can still see it was much hotter than the previous decade before it, but it still puts it at the top 3 hottest year. Now, as I mentioned before, our greenhouse gases relate directly to temperature. And specifically, we're seeing a strong correlation between carbon dioxide and our temperature variations that we see. So in blue, we can see the measured temperature since 1880 occurring globally. And in green, we have our carbon dioxide level. So we can see this trend where it has been positive even since the 1880s, but in the more recent period, we've seen a much sharper increase in the carbon dioxide levels and the associated temperatures, where we've seen globally surface temperatures rise by upwards of 2 degrees Fahrenheit since the early industrial levels. We've also seen a strong climb in the concentration of carbon dioxide, where we are below 280 parts per million of carbon dioxide in 1880, and we are nearing 430 parts per million of carbon dioxide in present day. And this has been strongly corresponding with the use of fossil fuels during the industrial activities. Now, there are some variations in temperature. You can see it does fluctuate in the short term, but we still see this overall positive trend through time. Small changes such as solar variation, El Nino and La Nina cycles, which impact rainfall and things like that, can cause small variations. But again, we have this overwhelming correlation between increased carbon dioxide and temperature. Now, in addition to temperature increase, we also see a strong relationship with rising sea levels. So this is showing you the change in sea level from 1993 to present day. The change is in millimeters, but since 1993, we have seen about 3 inches of global sea level rise. Again, there are slight variations in here. These are tied with short-term climate cycles, again, such as the La Nina and El Nino. But we have this overall overwhelming trend in increasing sea level. And since the 1880s, we've seen a global sea level rise of upwards of 8 to 9 inches. Unfortunately, in the recent decades, we have seen an even sharper increase in the rate of sea level rise. So at the current rate, we're seeing about 1 inch of rise for every decade. In addition to global sea level rise, local places can experience regional relative sea level rise. So in some places, things like land motion, tides, currents, and winds can actually make it seem like the sea level is rising faster than in other places. So, for example, in Louisiana, the ground is actually subsiding, which means the sediments are sinking into the earth. And at the same time, the sea level is rising. So, to them, it seems like the sea level is rising at an even faster rate than is occurring globally, just because the sediments are sinking at the same time that the sea level is rising. So globally, we're seeing this significant amount of sea level rise, but regionally, some places can experience it even more quickly. Another impact that we see is the relationship between hurricanes and this changing climate. So we know that hurricanes can be fueled by warmer waters, and we have seen that in these central areas where hurricanes tend to form, a temperature increase of 1 to 3 degrees Fahrenheit has occurred. What this means is in warmer waters, we're going to have more precipitation, which leads to more convection within the hurricanes, and it causes stronger hurricanes to form. Studies have shown that hurricanes are also intensifying more quickly than they were 30 years ago. Now, it's important to remember that warmer temperatures aren't the only thing that impact hurricane formation. Things like temperature, um, wind direction, speed of currents through the atmosphere can all impact it, but we do see a relationship between warmer waters and strengthening of hurricanes. Now, we also expect to see heavier rainfall associated with these hurricanes as the climate is changing with warming temperatures, which leads to additional inland flooding. Our storm surges are expected to be higher. This is both due to the intensity of the hurricane. So when we have stronger storms, they're able to push more water up onto land. But if we also pair this with the increased sea level rise, we see that if we have 3 inches of sea level rise added to our storm surges, we're now flooding areas that wouldn't have experienced flooding beforehand. So it's predicted that we'll see an increase in the intensity of hurricanes, and they are predicted to produce more rainfall. However, they expect that the frequency will stay the same. So we should have stronger, wetter hurricanes, but likely the same amount that we have been seeing recently. Now, these storms are causing quite a bit of disruption to us globally. But if we look at this specifically for the United States, in 2024, we had about 27 different storms or climate-related disasters that cost over $1 billion or more to the United States. Now, in the Gulf here and in Florida specifically, a lot of our impacts are related to hurricanes. In 2024, Milton, Debbie, and Helene all caused significant damage in Florida. But across the United States, we see a lot of destruction related to other types of storms, such as severe thunderstorms, tornadoes, droughts, wildfires, and even winter storms. So in total in 2024, we saw about $182 billion worth of damage caused by these extreme climate-related storms just in the United States alone. Now, in Jacksonville, they did a study trying to assess what the top climate hazards would be. So they categorized the top 5 to be sea level, ocean chemistry, precipitation, storms, and heat waves. The darker red symbol bar at the top of each one shows what the current hazard related to these is, and the brighter red line, or the bottom one, shows what the expected hazard related to each of these would be by 2050. So you can see by 2050, sea level and changes in the ocean chemistry, so that would be things like ocean acidification, as well as increased rainfall, are going to be some of the largest hazards that we're going to have to deal with. Now, we already know that these problems to our climate have already begun hurting our natural resources and infrastructure, and they're going to continue to be impacted. So it's important to understand what is going to be impacted the most and then what we can do to work with this. So when we talk about the impacts of a changing climate, the things that we consider most are environmental, societal, and economic changes. So when we consider environmental impacts, the three topics that we start to consider are ecosystem disruption, biodiversity loss, and ocean acidification. So when we talk about ecosystem disruption, this could be the erosion or complete loss of a habitat due to things like weather pattern shifts or actual erosion or destruction by storms. As the climate begins to shift, animals and plants face the option of either moving to a new location, adapting, or facing extinction. Unfortunately, at the rate that we are seeing these changes occur, it's very difficult for animals and plants to be able to adapt quickly enough. An example for this could be the fact that coral reefs are dying due to increased water temperatures in the oceans. And if we lose the coral reefs, we lose the smaller animals that live amongst the coral reefs, which leads to greater fishery impacts and can cause an entire ecosystem collapse just from one species being impacted. When we talk about biodiversity loss, we're talking about how the rapid change in the environment is impacting the species' ability to adapt. So, as I mentioned before, although animals can evolve to change to their climate, they can't necessarily do it at such a rapid rate as we're seeing presently. Currently, we have about 2 million species that are at risk for extinction globally. This also causes environmental shifts. So in Florida, one of the major environmental shifts that we're seeing are the change of mangroves to them taking over salt marshes. Now, while mangroves are really important plant species in Florida, they help protect us from shoreline erosion, clean our waters, and provide habitat. They're taking over these salt marsh habitats. And salt marshes have quite a few environmental benefits for us as well. So even though we're getting more mangroves, it's not necessarily a good thing that we're losing the salt marshes due to this. And then we have ocean acidification. So as I mentioned a little bit before, ocean acidification occurs when we have an excess amount of carbon dioxide in the atmosphere. The ocean absorbs about a quarter of all carbon dioxide emissions, and as that carbon dioxide dissolves in the seawater, it causes the acidity to drop, so it becomes more acidic. Now we have a lot of marine organisms that have calcium carbonate shells that are impacted by this acidification. So things like clams, oysters, corals, and some types of plankton are not able to efficiently grow their shells if they're impacted by this. And that could cause a complete collapse of the fisheries that support us. Now, societally, we have a lot of impacts related to health risks, food and water insecurities, and displacement and migration of communities. When we talk about health risks, this can be things like higher temperatures leading to more heat-related illnesses and associated deaths. Air pollution is expected to worsen, causing issues for people with asthma, and can increase the risk of things like stroke and heart disease. Warming climates can also expand the range that disease-carrying organisms can live. So, for example, mosquitoes are now able to spread diseases like malaria more efficiently as the climate is adapting. When we talk about food and water insecurity, crop yields can be more variable. We could have droughts, heat waves, and floods that kill off crop yields, limiting availability of food. Water scarcity is an issue. We can have saltwater intrusion getting into our aquifers. The great glaciers are shrinking and droughts are becoming more common, making it difficult for people to get fresh water. And this can happen globally, these types of issues. Lastly is displacement and migration. So things like sea level rise and extreme weather are forcing people to leave homes that they've and communities that they've lived in for long periods of time. Currently, we're seeing about 20 million people per year that are being displaced by climate-related events. And this is likely going to continue. And we see that most of this disruption is tied to coastal communities. Lastly, when we think about economic impacts, we have to think about the cost that these disasters are having, the damage to our infrastructure, and potential agricultural losses. So, as I showed you before, the cost of disasters is increasing, with individual events causing upwards of $1 billion each. Things like wildfires, hurricanes, tornadoes can cause significant damage to our roads, bridges, power lines. And these can be not necessarily one-time events. As we see things like sea level rise continue to happen, we may have to repair this infrastructure over and over again or move it completely. And these long-term damages and maintenance are causing a lot of damage to our budgets. Agricultural loss is not only a societal impact, but also an economic impact, as we see food loss related to extreme weather, pest increase, and reduced growing seasons. We're going to see losses in food crop, which are going to increase food prices globally as food becomes more scarce. Now, this doesn't mean we all need to lose hope. There's a lot of work that's going on to start making changes for planning, mitigation, and adaptation. In Florida in 2021, we actually started the Resilient Florida program created by the Florida legislature, where they acknowledge that we are vulnerable to sea level rise, flooding, and severe storms. And so communities and local governments are working with their communities to bring resources, data sets, and develop vulnerability assessment plans. Now, there's kind of the three different things we can do when thinking about climate and how it's going to impact us. One is mitigation. So we can either try to limit the flow and increase of greenhouse gases into the atmosphere or create ways to actually remove those excess greenhouse gases. So an example of reducing these would be to reduce our global dependence on fossil fuels. So this could be investing in things like clean energy, such as solar, or using electric cars, things like that. Or we can help to enhance carbon sinks. So as I mentioned before, oceans, forests, soils, things like that are really good at storing carbon for long periods of time. So if we either preserve or create more of these natural green spaces, they will naturally pull that carbon down for us, and help actually remove some of these greenhouse gases. We can start to adapt, so we know that these changes related to climate are going to continue to impact us. Sea level is going to continue to rise, and we're going to experience extreme weather. So we can start doing things like lifting homes, planting living shorelines that can buffer us from storm-related impacts, moving our essential like water resources and infrastructure away from places where it's going to be damaged. So by planning ahead, we can adapt to the changes that we expect to see in the future. What's important to remember is that you do have a voice and your actions matter. I know when I think about how our climate is changing, it can sometimes feel overwhelming and like there's not a lot you can do. But even small differences can really make an impact, especially when enough people start doing them. So, just some things that you can do. The most important is getting involved, asking questions and staying informed, understanding ways that you can reduce your impact. All of you who came to this presentation today already are taking a great first step in trying to understand and grow your knowledge more about these topics. And with that, you can try to help promote more sustainability with your coworkers or at home and talk to your friends and family about how the climate is being changed and what we can do about it. You can do things like attend public meetings, join local groups, or even talk to your representatives about how climate is impacting your region. And the more people that are bringing up this issue, the more it will have to be addressed. Now, just for kind of small things you can do at home on a day-to-day basis, even though these things seem really small, again, if everyone were to take part in these, it would make a much larger difference. You can do such little things as looking for the Energy Star ratings on your appliances. These will tell you which are better at saving energy. Remember, even though the power in your house seems like clean electricity, it could be coming through from the burning of fossil fuels. So, doing things like switching to LED light bulbs, reducing your use of plastics. In your yard, you can use water more efficiently or follow the Florida friendly landscaping principles, which you'll learn about later in this series. Those all help lead to a more sustainable earth. You can start using green energy, so solar for your home, or buying a more fuel efficient or energy powered car. Or you can attend events where you can help restore natural systems, plant native species in your yard, or attend living shoreline or oyster restoration events. All these little things can help. So, what I want you all to take home from this today is that it's really not too late to plan. I know these problems can seem so extreme that it's difficult to know what you can do, but these problems are not insurmountable. The things that we do today will help us to improve our quality of life moving into the future. Now, if you're interested in learning more about this program, or you would like, if some of your friends couldn't make it today, or people in your community, you can sign up for this interest form or contact your local extension office, and we can tell you more about the program and how we can share it with others. So if you want to take a picture of that, I'll give you a minute to screenshot it or scan it. And I can go back to that as well. And then just a reminder, I wanted to bring up what our following schedule will look like. So next will be our green building and energy, followed by water, food, our Florida friendly landscaping class, and then consumption. So these are all going to be really wonderful webinars if you can attend the whole series. And with that, thank you. And I or some of my co-hosts will try to answer any questions you have.
Yeah, thank you so much, Megan. It was such a great presentation and a good introduction. We did have a couple of questions come in the chat, and I did try to answer them, but I can give you the opportunity to if you wanted to answer. Um, so one was about how gases are measured in the atmosphere. So how do we take those measurements? And I had said
Um,
that there's like measurements via like instruments on planes, ships, monitoring stations on land and on the surface of water, but I didn't know if you had something else.
Yeah, that's a good answer, Holly. We do have a lot of those stations, and a lot of the monitoring stations that we have in land we put in really strategic locations. So a really popular one is the Mauna Loa station, and that measures our carbon dioxide levels. And it's placed there because it's kind of as far away as we can get in a major place without having too much contamination. For example, if we were to put some of these monitoring stations in a really congested city, that could kind of mess up our values. So when we're taking these measurements, they're doing it from a bunch of different points around the earth. So we're getting uniform values, but they take care not to put it where it could kind of be influenced by any local impacts.
Great. And then another question, which we had a couple people put some answers in, but was how temperature was measured, like in 1850. So I had mentioned like thermometers, would have been used. And of course, as we sort of move forward in time, we have more like electronic instruments, but I didn't know if you had anything you want to add.
Yeah, so once the thermometers and electronic measurements were done, that's when we could start getting very accurate ones. Sometimes before that, they had to go off of more generic information, but on the longer time scale, we do use things like fossils in the record. We can look at things like isotopes, which are a type of element variation in some of our fossil records, and you can reconstruct temperature with that. And look at different kind of clues within the geologic record to collect those long-term temperature measurements for the deep past.
Cool, thank you. And then another question that just came in, which we will have a energy specific session next week, I believe. But the question was, what are some facts I can share with people opposed to the belief that solar panels help decrease fossil fuel usage? I've had folks argue that the material of solar panels and their efficacy are not worth it. So I don't know if you have anything to say, but we could always pin that question too for when we have our energy discussion.
Yeah, I think probably it will be addressed in more detail in our energy one. If you're okay waiting for it, Catherine, I think if you can attend that lesson, it'll have a lot more useful information than I can provide in a really short answer here for you.
She said, thank you very much.
Okay.
And I don't know if you wanted to go back to, I think it did show the schedule, and I think it is next week,
Yeah.
which we are going to have a really great speaker that will have a great focus on like green building. And so that certainly um, will be a good way of kind of learning more about that and hopefully getting your questions answered, Catherine. So great question. Any other questions? Feel free to put in the chat.
Oh, Holly, would you like to put up the survey?
Yes, I'm gonna just
Okay.
before you all while you're thinking about questions, I just have a quick poll. Just getting an idea if you learned anything new today and you plan on using any information you learned, or even better, telling someone else about what you learned today.
And it's only 4 questions, so you can do it really quickly.
Yes. Thank you, Hope. I look forward to seeing you next week and for seeing everyone else who'll be able to join. Um, I will be, like we had mentioned earlier, we're recording all the sessions, and so those recordings will be sent out to everyone who registered. So if people weren't able to join today in person, they will also get the recording, and if you were here, can refer back to it. So we're happy to take more questions in the chat. And thank you to those who filled out the poll. Anything else, Megan?
I think that's all. Thank you all for coming today. We appreciate it.
Yeah, thank you all for joining today, and we look forward to seeing you next week in future sessions.